Hi everybody. I'm going to give a talk today about SBOMs. I'm sure that's something that popped up in your radar at least once in the last few years. And I'm going to kind of do a quick intro to that. Before I dive into that, I'm going to give a quick backstory of myself. So I'm a serial entrepreneur, done a few startups. Early last year, I started to get really into SBOMs. And I'll dive into why that is in a second, and what that is in a second. But the reason why I got interested is because I started to see customer requests in one of my companies of customers asking for SBOMs. So that's why I was like, okay, this is not theoretical anymore. I've heard about it before. I've seen it before. It's not a new concept. But I started to really see commercial demand for it. So that's why I kind of started getting involved with that. And then we got part of a program under CISA in the US called Secure by Design. There is a kind of equivalent in the UK called Secure by Design as well. But the concept behind Secure by Design is essentially doing software and hardware proper, like doing security right from day zero, rather than try to shoehorn that or retrofit afterwards. So that led to another part than SBOMs. And then I kind of got involved with SBOMs in CISA as well, and kind of led a working group within there. So that's kind of quick backstory of myself. But what are SBOMs anyway? So actually, let's do a quick raise of hands. Who's familiar with SBOMs, who at least heard the concept? One. All right, that's a new record, actually.
Main the thing I think it does. So.
Ah, cool. Well, at least you'll come away learning something new today then. SBOMs stands for Software Bill of Materials. And the best analogy that I've heard, that I've kind of recycled myself, is that if you go into a grocery store, you pick up a chocolate bar, you can see that, take that chocolate bar, you can say, here are the ingredients that goes into the chocolate bar. Like, you don't see exactly the ratios of everything, but you see exactly what's in there. A software bill of material is the same concept for software. And that's might sound unsexy, and kind of is in many ways, but it is what that allows you to do that is actually really, really important. And it is essentially a manifest file that states everything goes into be a software. And that means really like every open source library you use, what license that's under, what version you're using, and all that stuff in there. Most frequently, it's done as a JSON file, but if you do really hate yourself, XML is an option. So there is an always option there. The reason why now is the time to actually get excited about this stuff is there is a lot of pivotal elements causing SBOMs to kind of become the norm these days. Well, not norm, but making its way into the mainstream. The first event was an executive order that started to mandate anybody who sells software to the US government must supply an SBOM. Otherwise, you're essentially barred from selling that to the US government. That then kind of made its way into EU Cyber Resilience Act, or CRA for short, which is coming into effect, I think it is next December. Which basically means for many industries, if you're selling software, you will need to supply SBOMs. Now, there are still some implementation details to be followed, and we don't exactly know what it's going to look like. But in many of the drafts, including one in Germany, I believe, which they already have a draft for, states you need SBOMs. And then my view of the future is every compliance framework going forward. We've already started to see this with PCI DSS 4.0, mandates SBOMs more or less. SOC 2 will probably require it. ISO will probably require it. So I would think, my expectation is that all the compliance framework will essentially require you to do this. So we're talking about what SBOMs are. We're talking about kind of why they exist, but what are they actually used for? Because obviously having a JSON file with some manifest data about, or artifacts about what your software composition looks like, it doesn't sound very useful, but generally speaking, is used for one or two things. The most common scenario, which is what I saw next talk event is at Monzo. Monzo is a big shop. They use a lot of SBOMs. They're using dependency track, for instance, for monitoring security using SBOMs. So you can chuck an SBOM at one of these many tools, and you get basically a CV report out saying you're affected by these CVs. Now, don't get me started what happened with the CV world this last month, but that's a whole different kind of worm. The other scenario is for license compliance audits. So if you worked at any larger enterprise or you interface with any larger enterprise, like open source licensing is a big topic. Like, what license are you allowed to use in-house? So one of the ways SBOMs can be used and is being used in a lot of these companies is basically as that. You basically chuck an SBOM and say, you can't use this component, it's GPL3, replaced with something else. Otherwise, you're not passing internal compliance. So those are generally speaking the two buckets of generating and why people are using SBOMs. Right. So now we understand what it's been used for. So let's talk about the actual generation of SBOMs. And generally speaking, there are three phases of this. And I'm going to dive into a diagram that's a bit maybe too detailed for this screen, but generally speaking, there are three phases. There is a generation, which is when you're actually authoring, as they call them in many of the authoritative documentation. So you're authoring or generating the SBOM, which is usually your CI/CD pipeline. Then you have the distribution, which is where you're taking it from wherever you generated it, spitting it into some kind of system where it's actually usable. And then the final part is the analysis part, which is like the security or the audits trail. And by the way, this is nothing new. All like Google, ServiceNow, all these big companies, they've been having equivalent of this stuff for decades. It's just now, it's just kind of making its way into like the mainstream as a standard format. All right, so when I got into SBOMs, I thought, okay, generating the SBOM, seen a bunch of tools out there, how hard can it be, right? So you take one of these many tools off the shelf, you run it, you point out some log file, you spit out an SBOM, boom, you're done. Or you go to GitHub and you notice, oh cool, GitHub has an SBOM feature. That's really clever, I can use GitHub, download SBOM. Oh boy, was I naive. It's the start of the journey is there, but it's a lot more complicated than that. So I mentioned in my introduction that I got involved and co-chaired one of the CISA working groups on SBOM generation. So basically we had this working group where we basically defined what does the life cycle for the producer look like for SBOMs. And this is kind of like the flow that was the output of that working group. So it starts with generation, which is using one of these many tools that's you usually pointed at a log file or some kind of environment. That spits out an SBOM, and I'm going to talk about the formats later, but it spits out some kind of SBOM. But what we realized was when we started actually using this in the real world, and actually looking at real data from real projects, because we took a really pragmatic real world approach to this, we realized that they're actually not compliant to what many of the mandates require. So there's something called NTIA minimum elements, which is kind of like the gold standard for an SBOM. So if you look at the executive order, for instance, they kind of hint that you need to provide your SBOMs that are compliant with NTIA minimum elements. That means you need to provide things like who you are as a vendor, like what license it's under, because there are a lot of data points in an SBOM or that are required in an SBOM that can't be inferred based on just a log file. In some specific environment, you potentially can do it, but generally speaking, you cannot. So we added the first step, which is augmentation. And that basically means tell the SBOM or enrich the SBOM with who you are as a company. Like who's the contact people in the company and all that. And then we have a next step, which is enrichment, which is you take the SBOM, but then it's in many times incomplete. So you might say, oh, I'm reliant on component foobar version 1.2.3, but you have no licensing data, for instance. So therefore, it's not complete. So we added this step called enrichment. And in enrichment, there are tools out there, and it's kind of the tool is getting more mature. But there's a tool called Parley from Sneak, for instance, that can use open data sets and like enrich the input and give it more complete data sets. And then we have a verification step, which basically means this thing you generated is actually valid. Like, is it even valid JSON? Let's just start there. Is it valid JSON to start with? Or is it just gibberish, right? And then there are specific specific tools. And then we added another step on there, which is signing. So if you're a little bit paranoid or if you're more serious, grown up in your security game, you probably want to do some attestation here, right? In particular, if you're using a CI pipeline and GitHub Actions and whatnot, doing attestation is super trivial these days with cosign. So you can just basically say, all right, sign this file for me so that if I distribute this to a third party and they download this file, they can see it has not been tampered with, because you don't make sure that it's in its original state, right? Because this is data that you're making pretty big judgment calls about a piece of software on. So you want to make sure that it's tamper-free. So that's why we added the signing part of it. And the last part is, this is something I've discovered in my personal journey with SBOMs in one of my companies. But even in a small company, you are not going to have one SBOM. Even for a small product suite, you probably have 15, 20, 30 SBOMs for different components. You have this Microsoft here, you have this Docker container here, you have this product here, this monolith here. All of them will have different SBOMs. So whilst in theory you could squash them all together and merge them into one single file, it will be very ill-advised because you lose so much insight into what the mapping and or logical organization is. So we've added a step called document linking, where you basically point to various, like instead of smash them together, you have like a parent that points to various components. You have like a tree structure. I'll show you that in a second, how that looks. And then the transportation we kind of covered in the first part, and then the analysis kind of also covered in the previous one. All right, so I've kind of left this out, but there is kind of a war going on right now in the SBOM world. So there are two competing standards. There is SPDX from the Linux Foundation, kind of started as a more of a licensing oriented format. So it kind of morphed into this beast that is very complex. And SPDX is very sophisticated, but also very non-human readable. So you have another standard, which called CycloneDX, which is a lot more human readable, however, not as feature rich as SPDX. So I don't know which one will be the winner, if there is a winner. If I were to pick, I think neither will be a winner, and hopefully will be an abstraction layer on top of that, where that's just a detail, like, do you want it in this format or not? But the tooling for that is not quite there yet. There is a project called Protobomb that is a meta layer on top of it, but it's like almost always referenced XKCD, right? And now there were 3 formats, right? So it's a little bit like that. We haven't seen a third format kind of gaining much momentum. There were some in the early days, but you don't really see much about that other than SPDX and Cyclone these days. So my projection is that Protobomb, or the likes of Protobomb, will become like the meta format, and you don't really care which one, because different vendors or different suppliers will use different formats, and therefore you kind of need to be agnostic. So that's where I kind of see it. So I'm going to rush through this because I know we're running behind on time, so I'm going to try to be effective with the time here. Generally speaking, I kind of want to group the tools for generating SBOMs in 2 buckets. You have generic tools that are not very specific in the sense that they can be pointed at many different languages, different platforms, like Sift and Trivia, for instance, they can support a wide array of tools. And then even, I'm not sure you've seen, if you're using Docker Desktop can actually generate SBOMs for you. Or Docker Scout actually, but it's behind the scenes, is shelling out to like other tools. So a lot of these are really there. I have dependency bot there, which can kind of can generate SBOMs, but I'm going to dive into why I wouldn't necessarily recommend using that for in a second. So they have domain-specific tools, and these tend to be the tools that are the most accurate. So there are like specific Python tools for generating SBOMs for the Python world, or for Rust, or for Golang, whatever you want. These tools, if you merge the camp of the 2 SBOM formats, so SPDX and Cyclone, and the language, you kind of have a Venn diagram there, and there is specific tooling. Both Cyclone and SPDX do provide tooling for many languages. Those tools tend to generate the most complete SBOMs because they can kind of use metadata that is very specific to the language. Now, I mentioned that that GitHub does allow you to download SBOMs, but the problem with that is GitHub is using what's called source SBOMs, and I'm going to talk about that in a second. Source SBOM long story short, source SBOM is like you use a log file for a given language, and then you infer whatever dependencies you have in there from the log file. The problem with that is it vastly varies from ecosystem to ecosystem how accurate that is going to be. So again, using a Python example, if you use a requirements.txt file, for instance, you may or may not capture all your transient dependencies in there because it will install it when you do an install anyways. Whereas more modern package managers like Rust springs to mind or Golang, they tend to have a much better comprehensive view on what actually goes into your software. And there are better tooling for Python, by the way, as well. If you look at Poetry or something like that, they have much better way of capturing dependencies, but most of the Python world is still running on requirements.txt files. So going back then to Python world again, one of the deliverables we had set out for ourselves in our working group at CISA was to contribute upstream. And for everything we did, we wanted to contribute upstream. Like if we're gonna work on, we did Keycloak, we did a few other projects that we contributed upstream or tried to contribute upstream. But one of the shortlists we had was Django. Obviously Django, a very popular Python framework. But as we dove into it, we realized we can't actually generate an SBOM upstream for this. It is technically speaking impossible to generate upstream SBOM for Python. And this is where you go into the problems with source versus build SBOMs. We're going to talk about more in a second. But what I mean is really this. If you see how Python is locking files, it's ranges. It's not precise versions. And there are good reasons why you're doing that in the Python world. But the reality is, because you're not pinning exact dependencies and transient dependencies, because all these will have transient dependencies as well, so it's not like they will not have their own dependencies. Because of that, it's impossible to contribute an upstream SBOM to, say, Django. So again, languages have very specific problem spaces to work with. All right. I kind of brushed over this already. Source SBOMs can be fantastic in more modern languages or with more modern package managers. But what you really want to look out for when you're working on using log files as your SBOM input is to make sure all the transient dependencies are not only captured, but also properly pinned versions all the way throughout. And again, what you really want is actually hashes all the way through. So like not only do you pin, but you also provide a hash of said package so that once you lock that into your SBOM and you attest that, that is it. Like you can't, there is very difficult to do a supply chain attack on that. So that's that. Now, I kind of hinted at this before, but when I started getting into the world of SBOM, I came from a very like practical perspective. I want to solve a problem, which is I want to provide to our customers a complete SBOM. So like when they come to us and say, what's in this product? I can say, here's an SBOM. Well, what you realize was very quickly that it's really difficult to capture an SBOM. And I kind of like alluded to this tree structure here. And what you end up is like you have a bunch of components, and these might be microservices, that might be a Docker container, and then and that's another thing. The runtime environment, your Docker file that you're running in your cluster, that should also have an SBOM because that is packages that are exploitable with licenses. So not only do you need for your source code, but also your runtime. So what that means is that even in a small project, you're going to end up with a ton of component SBOMs. And not only that, they can change on every CI/CD pipeline run. Because if you generate this in your CI/CD pipeline, that means that they can change like 10 times a day, right? Every single one of them. Which means that if you are going to contribute that and collaborate with your customers on these, you can't just email them every time your CI run. That's just not a practical way to do it, right? So they are dynamic objects, and then it gets even more complicated when you have like this structure. So we designed this kind of structure of product, project, and component SBOMs, and this is in an open source project we have called SBOMify that you can run yourself that I built, and that's the kind of structure we thought about around how to solve it in the real world. So we talked a little bit about security, because obviously security is really important here. Because if you're going to trust SBOMs, it is important that you really can trust what's in there. So I would say from a security perspective, if you're implementing this, attestation is kind of table stakes. And unless you're running some kind of really dated CI environment, attestation is pretty straightforward today. Particularly in GitHub and most hosted environments, it's pretty trivial to sign something. I said hashes is another one that you should do. Make sure that in your SBOM you have hashes. Again, very language specific. Some languages make it very easy. Other languages, you have to jump through quite a few hoops. So those are like the big thing on the security perspective. And then we have distribution. I kind of hinted at this. Like, I think handling SBOMs today is much like we manage source code in the 90s. Like, we were emailing patches to mailing lists. Like, that's very much the feeling that how SBOMs are handled. I've spoken to a lot of enterprise people, and that's literally it. They receive like SBOMs from their customers or from their vendors, and they just dumped into SharePoint. And like, cool. Well, that's not very useful. So what we're building is basically this platform you can chuck everything into, and then other tools can talk to. And the reason why this is very relevant as well is because this is intending to adhere to a new standard under CycloneDX called the Transparency-Exchange API. And that's an open standard that helps standardize discovery and sharing collaborations of SBOMs. So that's how I see the future of that. I know we started running low time here. I'm going to quickly skim over the last few tools. Analysis, dependency track, and Guac. If you want to analyze SBOMs, those are two of the best tools. Dependency track is great for finding security vulnerabilities. Guac is great for like really diving deep into SBOMs. But where SBOMs get even more interesting is actually not this. It's actually this. So the SBOM is here, but SBOM thinking is part of a bigger philosophy of how we actually express our software. So you have things like CBOMs, which is cryptographic bombs. You have things like SaaS bombs, which is like describe your infrastructure. So like, there's a lot of overlap here with infrastructure as code, where you kind of take that, but then you express it, and then obviously BOM is where it all started with, build material for like physical hardware. So that's what I'm really excited about, like being able to express the entire environment in a standardized way so that it can both be analyzed and collaborated and shared. So, what have I learned? I spent a lot of time in the world of SBOMs. It seems easy, but the tools are getting a lot better at a very rapid pace. They look a lot better today than they did 12 months ago. So there's a lot there. I think the biggest threat in deploying SBOMs is the unknown become a real problem. Because if something is missing in an SBOM, you can never assure that an SBOM is complete. That is one of the biggest problems, because how can you tell, or if it's something tool in the detection tool that just didn't cover it, right? So the threat of unknown is real, but I don't think we should make it a bigger problem than that. Like, it's still better than what you started with. So I don't know if you have time for Q&A, but I'm gonna pop this up on the slide. If you wanna learn more, I have a podcast called Nerding Out with Victor. I've had an episode with Alan Friedman, who's considered the father of SBOMs. There's an hour of me and him nerding out SBOMs. Also got an episode with Steve Springett, who's the founder of the CycloneDX standard, as well as Gary and Kate, who are two of the most prominent members of the SPDX world. And you can find all of them on vpeterson.com, Spomify at spomify.com, or at github.com/spomify/spomify. And if we do have time for questions, I can take a few questions.
I'll probably do them after.
That's fine. That's fine. That's fine. That's fine. No worries.
Thank you.
Thanks, everybody. Cheers.